There's almost nothing I would rather do than nerd out on biochemical pathways. So thank you for asking me the question about how does molybdenum interact with copper. And I think that is, first of all, really important to remember that we have minerals and we have trace minerals. So the minerals that we need a lot of are magnesium, our sulfur, our calcium. We have a lot of those minerals in our body. Our body can handle them and needs them. Trace minerals, we only need a tiny, tiny amount as cofactors in processes. So if we go over that tiny amount, yeah, then we're going to throw things off balance. So there is an interaction between molybdenum and copper, but only if you take too much molybdenum. So that's the take-home message of this whole video. Don't take too much of a trace mineral. So the RDA for molybdenum is 45 micrograms a day. The maximum dose that's recommended per day is 2,000 micrograms, which is equal to 2 milligrams. Don't take more than that. Because if you take more than that, then yes, you can throw off your copper, you can throw off your iron. And it's so intricately programmed for us already that we need to stay away from that more is better philosophy when it comes to trace minerals to keep us safe and healthy. Okay, so let's take a look at where does molybdenum work in terms of sulfur, because my work is based on sulfur. So in our bodies, we'll take a look at this biochemical pathway here. In blue, I have circled the movement of sulfite, which we don't want to have a lot of because it's irritating to us, moving into sulfate, which is benign and is excreted through the urine and used for a lot of other really important things in our body, structurally and functionally. And that movement is orchestrated by the sulfate oxidase enzyme, which is molybdenum dependent. Okay, so that's where the talk about molybdenum comes in with regard to sulfur. And why it's important. But again, you don't need to take excessive amounts of it. More is not better in this case. So going back into the 1960s, what they found was excessive molybdenum in cattle. And remember, they have a very different digestive system than humans. But what they found was that if there was an excess amount of molybdenum in cattle, it was manifested in what appeared to be a copper deficiency, right? So that's where the idea of the antagonism between those two trace minerals evolved. Something that's maybe more relative to us, but it's still a really old study, was a rat study where they found that they were trying to elucidate the mechanism, like what's happening here, how are these, it's not as simple as one is blocking the other in terms of absorption. Something's happening in the utilization of those in the body, and it's complex. So they found that if they gave excessive amounts of molybdenum to rats who are more similar digestively to us, then they noticed that those rats, if they had an excess of molybdenum and a low copper diet, they had a low growth rate, they had anemia and diarrhea. When they put the copper back in, then that alleviated the diarrhea and the anemia, but it didn't restore the growth. So there's a lot of, question about that. So what's actually really happening here? Obviously, there's a play between those two. And they actually, interesting, if you look at the metabolic cycle that I showed you earlier and how cysteine is involved in these rats that had the high molybdenum, low copper, when they added cysteine in, then there were fatalities. So that interaction is very delicate. Back to my main point, which is don't take too much of a trace mineral to keep all that in balance. Here's something from the National Library of Medicine. I was just trying to find out if there's any evidence for molybdenum deficiency And what they're saying is that it has not been observed in healthy adult people. So that would be rare, very rare. And if there is a defect in any of those enzymes that utilize molybdenum, like sulfite oxidase that we talked about, xanthine dehydrogenase, and aldehyde oxidase, then that's a fatal defect. Those humans do not survive. And then the only place where there was a deficiency found was in unhealthy subjects, people who were being in the hospital and being treated for inflammatory bowel disease. I think back in the day before we had the biologics, and it was only, steroids and surgery were the only ways to treat that inflammatory bowel disease. This was a Crohn's patient who was on total parenteral nutrition, TPN, and I guess they weren't getting enough minerals in their TPN because they were deficient in molybdenum. So it's a pretty rare to, and maybe even unheard of, to be deficient in molybdenum as a trace element. Okay, now coming full circle to the interaction between molybdenum and copper in humans. And this is again from the National Institutes of Health. Excess molybdenum intake has been documented to produce copper deficiency in ruminants, right, in cattle. So that is taking too much molybdenum and copper deficiency. This interaction is not considered to be of significance to humans. So unless there's something more update that I was not able to find, I think we're back to, quite simply, don't exceed your dose of molybdenum, 2,000 micrograms a day or 2 milligrams a day. Don't exceed your daily requirement of copper, 900 micrograms a day. The majority of this you're going to be getting from your foods, and it's easy enough to look up what food sources there are for those two trace minerals. And one last thing, because I just ended up on a Reddit rabbit hole talking about this topic to see if I can find anything that was a current study. And what I did find was a lot of misinformation talking about how molybdenum and copper compete for absorption in transport absorption from the inside of your digestive tube into your body, and they don't even use the same mechanism. So copper has a transporter that it uses, and molybdenum is passively diffused. So I can't imagine them being competitive in terms of the absorption either. So it's really important not to rely on non-scholarly articles, on AI generated, especially because if you ask a question to an AI, and if that's the first thing that comes up on your computer, just go right past that and look for something scholarly, because the AI generated information is just reinforcing what you want to know.